Okay, so in this video, we're going to talk about Green's theorem. Green's theorem is something that is specifically for R2, unlike the theorem about line integrals, which was for Rn. Green's theorem is just for R2. So if R is a nice region in R2, so what do I mean by a nice region? Basically that it's all one piece and that its boundary curve, so this part right here, is a smooth curve. It doesn't have any corners or anything like that. So what Green's theorem says is that the surface integral of this function, so Q and P are functions, the surface integral of that function over R is equal to this line integral around the boundary of R. And remember we put the little circle there around the integral to let us know that we are doing the integral over a closed curve. In other words, a curve that has the same starting and ending point. Okay, so Green's theorem, again, it's only for R2, and it gives us a way to either go from a line integral to an area integral or from an area integral to a line integral. Now, why do I say this is like a two-dimensional version of the fundamental theorem of calculus? Well, notice on the left-hand side, we're integrating a derivative, a type of derivative, over a two-dimensional region. On the right-hand side, we're integrating not a derivative, but the function over a one-dimensional region. Okay, so we have two-dimension region on the left, one-dimension region on the right, derivative on the left, no derivative on the right. How does that compare with the fundamental theorem of calculus? Well, let me get back up there. The fundamental theorem of calculus, what do we have? Let's look at this part of the fundamental theorem of calculus. We're integrating a derivative. Little f is the derivative of big F. We're integrating a derivative, and on this side, we don't have a derivative. We have the function itself, and f of b minus f of a, this is kind of like doing the integral of a function over a zero-dimensional set. You haven't learned about that yet, but as you take higher math classes, you will. So we have an integral of a derivative. We have a one-dimensional integral of a derivative, and here we have a zero-dimensional integral of a function. Okay, so how does that compare again with the Green's theorem? We have a two-dimensional integral. On the left-hand side, we have a two-dimensional integral of a derivative. On the right-hand side, we have a one-dimensional integral of the function. Okay, so in the next couple of videos, we'll apply this to solve some problems.